every semester I sort of try some new stuff, you know, think about like what I'd like to improve and try to do something. And anyways, this semester I collected just so much more work than usual, and it's resulted in just this total like shit show of like not getting any work back to people. And I mean, it's embarrassing and it's not helpful, you know, to you guys. So anyways, here's what I'm doing. It's not a perfect solution, but I am, because of that, just bumping everyone's scores up 5%. Total, at the end of the semester, every score is getting bumped up 5%. So that's like a apology offering because I haven't gotten any of your homework back. So, okay. And the next thing is exam 4, I guess, is a week from today. So the 25th. And that will cover everything up through friction. Is that what I said before? It is, right? Through friction. Okay, so first today, if anyone has any homework questions or questions about the test or whatever, I'd be happy to answer questions. And then we're just going to do friction questions on the board. So first, does anybody have any? Yeah. Okay. Do you happen to have it with you? So structures number 7. It looks like this. You have a fixed joint between the ground and a vertical beam. And then that makes a pin joint with a T-shaped beam. That's all one member. And this here, the connection here is a roller. And then this is a pin joint. These angles are both 45 degrees. This length is 1.5 meters. This is 1 meter. This is 2 meters. And then there's a downward force of 2,000 newtons here. And we want to calculate the external loads on each member. All right, so I'm going to call this joint A, B, C. And I'm going to call the vertical one member 1 and the T-shaped one member 2. So free body diagram of member 1. At A, that's a fixed joint. So we have a full force vector and a couple. I'll call that MA. And then up here, that's a pin joint. So that's the force on member 1 by member 2. And then at point, whatever I called it, with the roller, C, the force applied by a roller is perpendicular to the surface it rolls on toward the chosen body. So it has to be like this. I'm just going to call that RC. Why don't I call that F12B or something? Well, we've never done that before, so that'd be weird. But just remember, forget the question. Here's my statement. Don't use that double subscript notation for scalar variables. We know the direction of that force, and so the variable is a scalar, and so if you use that double subscript notation, it can make you get your signs backwards. Okay. And then do these have masses? No. So F moment. I'll choose this as the about point. So first, that force RA, that has no row vector. The force is RAX, RAY. Cross product is 0. Then the moment, we don't have to worry about any of this stuff. We just add that on the moment column. And then the force RC. We have to figure out, let's see, that is 1.5 minus 1.414, which is 0.086. Okay. Say it's that. Okay, so let's call that 0.086 because Fred has verified that that is correct. And then the force is negative RC 0. And the cross product is 0.086 RC. Okay, good. And then the row vector for F12, that is 0, 1.5. The force vector is F12X, F12Y. And so the cross product is negative 1.5 F12X. So we have 3 equations. Newton's second law says negative RC plus F12X is equal to 0. Second equation says F12Y is equal to 0. And the third equation says 0.086 RC minus 1.5 F12X is equal to 0. Nope, I'm missing one. Plus MA. is equal to 0. We have for variables so far. This triangle so this length to the midpoint of that triangle, like this, is 1 times cosine of 45, so 0.7071. This one's 0.7071. So the two of those together is 1.414, and then
I see.
Yep. Subtracted from 1.5.
Okay.
Yep.
R8X, R8Y. Scroll down.
Nope, those are in there. What? Oh, and yes, I did. Thank you. Yes. Okay, so negative RC plus F12X plus RAX is equal to 0. And then F12Y plus RAY is equal to 0. And then the moment equation stays the same. And so the variables are the vector RA, vector F12, and the scalar RC, and the scalar MA. So 2, 4, 5, 6. So 3 equations, 6 variables. And then free body diagram for the T-shaped one, member 2. Up here we have the force on 2 by 1, that's negative F12. Here we have the applied downward force of 2,000. And here, Newton's third law says this has to be RC. The rho F moment. And then this one, you have to deal with some sort of non-trivial geometry, I guess. Let's see what's going on here. So for an about point, I'm going to put the about point here. And soon you will see how smart a decision that is. So, yeah, the row vector going from here to where that F12 is applied, that's 1 times cosine and sine of 135. So that's negative 0.7071, positive 0.7071. The force vector is negative F12x, negative F12y. Cross product is 0.7071 F12y plus 0.7071 F12x. The row vector to where the 2000's applied is positive 0.7071, positive 0.7071. The force is 0, negative 2000. And the cross product is negative 1414.2. And then where RC is applied, that is at 1 times cosine and sine of 225. So that's negative 0.7071, negative 0.7071. The force is RC 0. And the cross product is 0.7071 RC. noticing. And then equation 4 says negative f12x plus rc is equal to 0. Equation 5 says negative f12y plus 0 is equal to positive 2,000. Move that to the other side. And equation 6 says 0.7071 f12x plus 0.7071 f12y plus 0.7071 rc is equal to positive 1414.2. Did we introduce any new variables? I hope not, because we only have 6 equations. So variables are still the same as after the last one. 6 equations, 6 variables, and you can solve it. That was like, you know, you should on YouTube for So Pitted Dude. Type in So Pitted Surfer Dude. Yeah, okay. That's what I was doing. Right. So let's do some friction problems. Okay, so let's say that you have I don't know if this drawing is really going to help anything, but let's say that we have 15,000 newtons being supported by this square-threaded screw. And the screw has a lead of 0.005 meters and the radius of the screw is 0.01 meters. So what's the couple that needs to be applied to the screw to initiate motion up if the coefficient of static friction is 0.05 and the coefficient of kinetic friction is 0.03. Okay. Any questions about that? Okay, get in groups and do that on the board. And if you have questions